Hello, Sushim here. What I have here is a breadboard, a BB830 solderless busboard, I believe. This breadboard can be used to model real circuits out of raw wires, switches, and logic gates. They all come in this compartment right over here, where we can have a battery, sets of wires, sets of resistors, logic gates, switches, and of course, light bulbs. Let me show you an example of what you can make on the breadboard. So this here is a breadboard modeled after this logic diagram shown here. There are jumper wires to a battery that connect to the breadboard circuit at specific locations. For instance, the red wire is connected to the left of the small transformer, which reduces the voltage of the current from 9 volts to 5 volts. This is very important because the breadboard circuit cannot withstand a voltage of over 7 volts, from which the so-called black smoke of magic starts to appear from a fried circuit. The black wire is connected to the negative terminal of the outer breadboard, which represents the current going back to the battery. Notice that many of the components in this circuit are connected to the positive and negative terminals of the breadboard. This is because the positive terminal represents the hot wire or current going from the battery after it has gone through the transformer. The wires connecting to the negative terminal indicate the components of the circuit are grounded. This is important as these wires help to direct excess positive charge from the wires, preventing the likelihood of fire, sparks, and electrocution. The final wires in the circuit are used to light a bulb. If conditions are right, then current will go through the bulb and light it. The current from the bulb will go through a resistor connecting to the negative terminal, back to the battery. Now that we have gotten the basics of the circuit out of the way, it is time to talk about how this breadboard circuit simulates the logic diagram. There are wires connecting to the 4 on-off switches that when turned on in any combination, the logic gates that connect the switches through wires will determine whether the bulb will light up. Switch number 1 represents the A variable, 3 represents the B variable, 5 represents the C variable, and 7 represents the D variable. The left logic gate represents the AND gate, where both inputs must be true for the output to be true. The middle, the OR gate, where either one input must be true for the output to be true, and the right, the NOT gate, where the input is negated from true to false or vice versa. The wires connect the variables to certain areas of the logic gates, where the inputs are evaluated based on the condition represented by these gates and the logic diagram. The outputs are then wired to the next necessary gate as per the logic diagram. To determine whether the LED lights up with certain variables turned on, I have created truth table rows with either variables being true, T, or false, F. As you can see here, if I turn on the switch for some variables, lighting up the respective lamps, and off for others to represent their truth value, the overall condition for the circuit changes. So there you have it, how to model a breadboard circuit out of a logic diagram. The wires used in this video can be cut and spliced from long stretches of wire with the wire splicer that can be found in any hardware store. The rest of the components in this circuit can be found in some breadboard kits, but not in others. Thank you for watching, and I hope this video was helpful to you.